Okay, imagine this. What if an AI could read an entire book in the same amount of time it takes you or me to read just a single page? Sounds like sci-fi, right? Well, we're about to dive into a truly revolutionary idea from a new research paper that's making this possible. And the secret? It's all about teaching AI to see text not as words, but as pictures.
We look at these huge, large language models, and we think they're practically magic, right? Like they can do anything. But here's the thing, there's a really surprising paradox at their core. For all their incredible power, they have a pretty serious weakness.
So what is this weakness, this bottleneck? Well, it all boils down to a pretty simple question, actually. What happens when you try to feed an AI a really long document? I'm talking a 100-page report, maybe even an entire novel. The answer? It kind of chokes. It really struggles. And this is what people in the field call the long text problem. And it's a huge deal. Think about it. The more text you give an AI, the more bogged down it gets. It becomes super slow and super, super expensive to run. Okay, so let's get just a little bit technical for a second. The reason this happens is something called quadratic scaling. Now, that sounds complicated, but the idea is actually simple. If you double the amount of text you give the AI, you don't just double the work it has to do, you square it. That cost just explodes, which makes reading long stuff, well, basically impossible for today's AIs to do efficiently.
So, how do we get around this massive problem? Well, the researchers behind a model called DeepSeek-OCR came up with an absolutely brilliant solution. They took that old saying, a picture is worth 1,000 words, and they decided to take it literally. The official name for this is context optical compression, and the core idea is just so clever. You take a whole page of text, which an AI usually sees as thousands of little pieces or tokens, and you smash it all down into a single compressed image. And that image? It can be read using way fewer vision tokens.
And this is where you really see the magic. Let's put some numbers on it. A page of text that an AI would normally have to process as, say, 1,000 separate text tokens can now be understood as just 100 vision tokens. That's a 10x reduction in complexity. Just wow.
Okay, so how does this actually work in practice? Because this isn't just some theory on a whiteboard. This is a real working model called DeepSeek-OCR, and it was built from the ground up to do exactly this: read text as if it were a picture.
And the whole process is surprisingly elegant. First, you feed the document page in as an image. Then, a part of the system called the deep encoder kicks in. Think of it like a super powerful scanner. It zips through, grabs all the important features, and compresses the image into a tiny set of vision tokens. And then finally, another part, the decoder, reads those vision tokens and reconstructs the original text perfectly.
All right, so the big question is, does it really work? And this is where things get super exciting. The data in the paper is pretty clear. This isn't just a clever party trick. It's a genuine game changer for AI efficiency.
So the magic number they were aiming for was a 10x compression ratio, and they hit it. That means taking roughly 1,000 text tokens and squishing them down into just 100 vision tokens. That's the benchmark for success here.
But here's the part that really blew my mind: the accuracy. The paper says that even at that 10x compression, the model can rebuild the original text with around 97% precision. That's almost perfect. It's basically lossless, which is just incredible. And this table here really shows you the trade-off, right? If you're compressing, say, 800 or 900 text tokens, you're getting almost 97% precision. It's fantastic. But even when you push it, really push it to over 1,200 tokens, the precision is still at 87%. That's still ridiculously good. And when you put DeepSeek-OCR head-to-head with other big models, the difference is just night and day. On a key benchmark, it actually outperforms a leading model called Miner U 2.0 while using less than 800 tokens to do it. The other model, it needed over 6,000 tokens. That's just a crazy difference in efficiency. It's doing so much more with so much less. Okay, so this is all really cool, but what does it all mean? What are the bigger implications? Because this isn't just about reading PDFs faster. This is pointing towards a completely new way of thinking about AI memory itself. Remember that long context problem we started with? Well, this could be the solution. Think about it. An AI could take its past conversations, compress them down into these efficient little images, and build a kind of memory. A nearly infinite, super efficient memory that would let it remember everything, just like we learned from our own life experiences. And this leads to an even wilder idea that the researchers talk about: creating a forgetting mechanism for AI. Now hang on, because this is cool. Instead of an AI just deleting old info, what if it faded? Just like our own memories do. The older a memory gets, the more compressed and blurry it becomes, using up less and less space.
So here's how you could actually build that. Your most recent conversations, they're stored as super high-resolution images. They're crystal clear. But as time goes on, the system could automatically start to downsize them, making them a little blurrier, a little less detailed. And stuff from way, way back, that might just be a tiny, highly compressed thumbnail. It's still there, but it's taking up practically no resources. And that leaves us with a pretty wild final thought. For so long, the goal has been to give AI a perfect computer-like memory that never fails. But what if that's been the wrong approach all along? What if the real key to building a smarter, maybe even a more human AI, is teaching it how to forget?